Hello, my name is Anna. That was beautifully pronunciated, by the way. Thank you very much. And I'm a senior data scientist at TIBCO. I've been doing data science for 15 years, which means I'm actually older than I look, luckily, for now. So we won a Cloudera award for doing some really cool connections to Hadoop data. I work with a product called TINCO Spotfire, and it's a visualization engine that allows you not only to connect to your data source, whichever that may be, so it can be Oracle or Hadoop or SAP HANA or whatever else, text files, and it allows you to draw visualizations that can bring meaning to what happened in the past and why did that happen. So that's the first two boxes, measure and diagnose. But from the same interface, you can also launch predictive and optimization calculations, and for that, R is one of the possibilities of engines that we can use. We can also use SAS or MATLAB, and we can use our own version, well, interpreter of R, which is TERR, of which I'll speak longer. But basically, you can run any calculations you want on that data. And finally, imagine that you make a predictive model based on the stock that you have and based on everything you know about your clients, you want to offer those blue sweatshirts that you have way too many of and can't get rid of to those people who really love blue sweatshirts and really want to hear about the promotion for this. So you make a predictive model, and then you deploy that model in real time from Spotfire by pressing a button, which means that now people that are going to be on your website are going to be receiving their offers for blue sweatshirts if that's what they want, and not if they prefer red. So if that makes sense, that means that Spotfire is the only engine, and I can say that in confidence, that allows the business end user to have an easy interface to handle all those 6 tasks of analytics maturity. So how does that work on Hadoop? Outside, I can show you the demos. Here, I'm just going to talk about them. But from Spotfire, because the data can stay in the database, we can interpolate the database to find out and visualize large numbers of rows in a very fast way. So, for example, we have an experiment with 12 Hadoop nodes where we're interacting with 834 million lines, and we get half-second performances in terms of how fast those visualizations can update. So, yes, we can visualize big data. The other thing that I promised you was that we could have with Spotfire a simple interface for launching mathematical calculations. And that can be with TERR or MapReduce or H2O as Spark. And that can be using a number of different models, from logistic regression and clustering, random forest, sentiment analysis, or any other mathematics you want to implement. And it can be made to answer a number of different use cases, from churn to identifying sentiment, etc. I have spoken how we can launch all these mathematical calculations, and of course, we're in an R conference, so they can be done in R using our scripting language. Now, at TIBCO, we were the original developers of the S+ language, which is the predecessor of R, and it was used by companies worldwide until, it still is today. There's something with the sound, so I'm going to step back and hope that works better. So then, of course, the R language became driven throughout the world by academics, and now we've developed TERR, which is an interpreter for the R language, whereby you write R, but it gets interpreted by TERR, which does a better, more efficient memory management and can run faster and can be more robust. So this was an engine that was built from the ground up, so it's not just a repackaging of open source R, it's actually our motor, our rules, we say. So there's a developer edition for this that is free of use that we would be happy for everyone to try and play with. TERR can be run from RStudio as well, so you can just go to Tools and Global Options and point RStudio to run TERR. So basically, there's zero learning curves for our programmers already. And TERR can run in memory or in database in Hadoop. as well as it is embedded inside of Spotfire in a very natural way. So I've been saying that TERR can be faster than R. So this is an evaluation of an example. So here we're generating some data, some 500,000 points with binomial and normal distribution. And on the same machines, we're having fitting a GLM model on R and TERR. And we can see that R takes 107 seconds, whilst TERR took 17 seconds on the same code on the same data. Now, when we're doing model scoring, it can be even faster. So R is taking 84 seconds, and TERR is taking 1. So we're talking of an increase in performance of 7 to 84 times larger for this specific use case and example, which can be very relevant when it comes to launching things in production in business environments or in big data environments. Results can change from package to package, so we encourage people to test with several. This is an example of applying the E1071 package, and we can see that on the red chart, as data sizes increase, the red line is open source R, and TERR is the blue one. We can see that the difference in efficiency in TERR increases with the larger the data sizes. One thing is we're now going to be launching TERR 4.0. It is compatible with about 5,000 CRAN packages. There's still another 2,000 it's not compatible with, but you can still reach them by using a package called RNR, which allows you to call out to R-only packages from within TERR, from within the same environment. So basically, you have the world of R, but faster. And R is embedded in Spotfire, as well as our our real-time engines, as well as it can be embedded into your own software, for example, without having any licensing issues or from the fact of being open source. So now I'm finally going to skip to here and talk a little bit about how we can run TERR code inside of Hadoop data to run a number of different use cases. So at the bottom layer here in orange, we have the HDFS files distributed over several nodes where the data lives. So what we do is install TERR on each of those data nodes so that each piece of TERR will run the calculations on its own piece of data. So the end user will just interact with a click point selection of the specific steps he wants to run on the server. So I'll go back a slide. So for example, this is an implementation of how you could run MapReduce jobs on your data. So at the top part, the end user can choose the role that each of the variables is going to play on the calculations. So for example, he's going to have some keys, so he's going to make a linear model for however many combinations of country and client that there are, and then, which means that, part A and B actually correspond to the mapping step of MapReduce, so how to organize the data in the clusters so as to facilitate my calculations. And step C is what calculations are going to be run. So here we have some R code. The user can actually come here and change what he wants, or we can just allow a drop-down menu for different possible functions to be run if we have a less R-savvy user. So finally, you have here the option to either run locally on a subset of the data to see if you're getting the type of results that you want. And if you are, you can then deploy it in Hadoop to get the full-blown results. And then eventually, you've run a linear model on 9,000 combinations of client and customer, so you get the results back within Spotfire to consume. So here you have 9,000 lines of results that are the intercept and the coefficients of the model on that data. And then you can make your own business decisions with. So the idea is the end user can be enabled to have an easy-to-use interface to apply complicated maths on a complicated structure, whilst he's having a simple interface where he can do cool things. So what happened there? From Spotfire, the end user has a click to run and to get the map and reduce information. This gets passed on to Hadoop streaming, which organizes the data in the nodes. The TERR runs the R code within the nodes in parallel and gets the results back into Spotfire for visualization. So yes, that's TERR and doing our written calculations in Hadoop. The thing is, sometimes we don't always want to have 9,000 different models per every combination of customer and country that you may have. Sometimes you want to have one model for all your data. And you can do that with H2O, which is a motor for running distributed calculations on large data, and particularly on Hadoop data. So what happens there is that H2O interacts with the Hadoop streaming so as to get data communicating between the nodes so that you have one summary for your whole data. And here, again, you can build an easy-to-use interface for the business user to select which variable he wants to predict, which predictors he wants to use, where's this mouse again? Which models he wants to run, press the button Fit Model, and on 1 million lines of data, we can get H2O to respond in 3 seconds, which is pretty darn fast. Finally, so we've made our model here. In this case, we know that if you add, we have those coefficients, the observed values of the explanatory variable, so we can make our prediction of, I don't know how much each person is going to buy of those blue sweatshirts, and then make our offers accordingly. Finally, I promised you that it was easy to deploy models in real time, so you can do that by just pressing the button at the bottom. That's a funny little construction button at the bottom. And it sends the model information, which is straight to Streambase, which are the real-time engines that implemented in real time. So yes, our final promise. So from Spotfire, you have an easy-to-use interface where the user can interactively visualize his big data, launch mathematical calculations of any type. We have seen that TERR is cool. I hope you agree by now. We have seen an interface where the user can interact with the results and deploy models in real time. Was that too fast?
Perfectly fine. Thank you very much.
Thank you.